Hello class, this is the first example on mathematical induction applied to divisibility tests. So let's get straight to it. This is the question that we had from the previous video, but now we're going to use the actual method of mathematical induction to prove that any number, well, for any n greater than or equal to 0, so 0, 1, 2, 3, 4, 5, and so on, if we substitute that into n, we want to prove that any number that this generates is divisible by 80. So the first statement when it comes to divisibility tests, we say if the expression is divisible by 80, then we can say that the statement 3 to the power of 4n minus 1 can also be of the form 80 times m for any integer m is greater than or equal to 0. So any number that this generates from substituting m can also be generated by 80 times some m value. It has to be an integer, sorry. So let's keep going. So from here, the method looks a bit similar to the first set of questions. We always let n equal the smallest possible value in the given domain, so 0. 3 to the power of 4 times 0 minus 1 equals 80m. 4 times 0 is 0. 3 to the power of 0 is 1 minus 1. And we get 0 is equal to 80m. Well, then this is true for n is equal to 0, since we can say that m is equal to 0, and that is within the given domain of this statement. So we've proven it true for the first value. Step 2, as before, we say for any integer k is greater than or equal to 0, we'll assume that the statement is true for n is equal to k. So we now get the expression 3 to the power of 4k minus 1 is equal to 80m. Now we need to prove true for n is equal to k plus 1. So now our expression is 3 to the power of 4 k plus 1 minus 1 is equal to 80. So let's focus in just on the left hand side of this equation. So we're going to expand this. This gets us 3 to the power of 4k plus, expanding that, we get 4 minus 1. Now here's where some work needs to be done. Just to get across what I'm about to do, imagine this expression as 3 to the power of a plus b, which looks just like it, right? Well, by index laws, this is 3 to the power of a times 3 to the power of b, because remember, the same bases, the indices will add. So we're going to split this apart into becoming 3 to the power of 4 times 3 to the power of 4k. You'll see why I ordered them in this manner. Because now, whoops, sorry, I nearly forgot, there's that -1 there. And so now we need to make this change into something that looks like ATM. Well, because we assumed this to be true, we're going to use this expression to help us down here. So now take a look. We're going to rearrange this to become 3 to the power of 4k is equal to ATM minus 1. Substituting that, we get 3 to the power of 4. If you type it into your calculator, you get 81 times, now 3 to the power of 4k can be substituted with that value. ATM minus 1 minus 1. Let's be consistent. Expanding this, rather than just multiply it out, it's going to be 81 times ATM. So I expanded this out. And now I'm going to expand this one out. We get negative 80. I just realized. Big mistake here. This should have been +1. That +1 should be here. And this gets us plus 81 minus 1. Apologies for that little mistake. Glad I caught it now rather than later. Now, I want you to take a look at this. Since this is just multiplication, this is 81 times 80 times m. Because of multiplication, we could rearrange it like so. 80 times 81m, and then this one is just going to become plus 80. Factoring out 80, we get 80 outside of 81m, sorry, not minus 1, plus 1. So we factored out 80 out just like this. Now from here, we're nearly done. We now have that expression. Now we can say that this, since this is of the form ATM. Okay, so can you see how this expression is actually looking like this? 80m, where all of this is some whole number. Because remember, m is a integer. So any number that we put in here is going to be a whole number. So this entire expression looks kind of like this. So then therefore, we can just say that it is that. So we can say that it's ATM, which is equal to the right-hand side of what we were trying to prove, this bit here. And then there we have it. That's the end of the proof. We can say then just from step 1 and step 2 by mathematical induction the statement, we can say, sorry, not just the statement, we can say by mathematical induction 3 to the power of 4n minus 1 is divisible by 80 for all n is greater than or equal to 0. Actually, no, we should specify a little bit more. That's for all integers. All integers, there we go. All integers, n is greater than or equal to 0. So, I hope you can see that there's not much more difference other than this first part. And that's essentially it. It looks pretty much the same. it's the same principles being applied. And yeah, I hope that gave you an insight into the method being applied to divisibility tests. Hope to see you in the next video. Best of luck.